Okay, here's the review for the exponential and variation functions test. The first question here says the bacteria problem. Suppose that the number of bacteria in a culture in your biology lab is increasing exponentially with time. On Tuesday, there are 2,000 bacteria in the culture, and the bacteria is growing by a common ratio of 2.27 times per day. Part A says to identify and define your independent and dependent variables. Well, your independent variable is going to be the number of days, because that's when you're looking at it. The dependent variable is going to be the number of bacteria. The A value is your initial startup, because your equation is y equals a b raised to the x power. So your A is your initial startup, so it's 2,000 bacteria. The B value is your common ratio, which is 2.27. And since this number here is greater than 1, it is a growth. And the equation would be y equals 2,000, 2.27 raised to the x power. How many bacteria would there be in 1 week? And we can use a calculator for that. Okay, so I am going to toggle to the graph, or just the scratch pad, and I'm going to put in 2,000, parentheses, 2.27, in parentheses, and this is going to be raised to the 7th power because this says 1 week, and 1 week there are 7 days. And remember, our independent variable was the number of days, not the number of weeks. So we press enter, and we get 621,171. And this is bacteria. This next one says, how long will it take for there to be over 1 million bacteria? For this one, I would use the calculator by putting the equation in the graph. So I would toggle to the graph, and I would go y equals, or the function of x equals, and it was 2,000, parentheses, 2.27, in parentheses, and raised to the x power. Press enter, and then you can press Control T, which will give you your table, and then you can just go down until you see that it is over 1 million, which would be 6 place values. And if you see it right there, it kind of raises up and kind of tells you. So when will there be over 1 million? And it would be 8 days. Okay, the next problem. Suppose you photocopy an image with a width of 20 centimeters, reducing it by 20%. Then you make a copy of the copy, reducing that image by 20%. You continue this process through 5 reductions. Write the equation for this reduction and fill in the table for the 5 reductions. Okay? So what I would do to write the equation, since this is a reduction, it's telling you it's a decay or it's going to decrease. So we take 1 minus our percent, which is 0.2, because we move this to the decimal over. And if we wanted to, we could see it as the equation this way, or we could simplify 1 minus 0.2 Remember, this is your rate R in your equation, and I would simplify it so we get y equals my initial, which is 20 centimeters, and my rate of change would be 0.8 raised to the x power. Now we could plug it in here, and just as a reminder, you can write it like this, and it is the same equation. Okay? And we could figure this out by hand, step by step for the table, or we can just go ahead and put it in our calculator. And since I already have the calculator set up to have a graph in a table, I am going to just press my mouse over here and go tab, and I'm going to arrow up, and I'm going to delete this, so backspace. And I want 20 parentheses and 0.8 in parentheses raised to the x power. Press enter. And now if I go over here, I can see that 0 is 20. I'll zoom in so you can see it. Okay, there we go. 0 is 20, 1 would be 16, 2 would be 12.8, 3 would be 10.24, and scroll down, 4 would be 8.192, 5 would be 6.55, and I'm just going to round that one to the nearest hundredth. If you wanted to, you could write the whole thing. And that would be the answer for the table. The next part of the question says the size of the pixel on the copy machine is 0.0015 centimeters. Anything smaller than this will not appear on the copy. How many copies will it take for the image to be so small it will no longer be visible? And so we could just use this, and we could keep going down until we have 0.015, and we can see right here it would be about 43 copies. Now, the other way that we could do that is we could go back to the toggle the home, and we could go menu, and we could go number 3, algebra, numerical solve, and then we can put in our equation, which is y, which we want to be 0.01, oops, sorry, back, 0.15, so 0.0015, and then that equals our starting, which was 20, our rate of change, which was 0.8, and then in parentheses, and we want to raise that to the x power, and then I'm going to arrow over so it goes down so I can put comma, see that, x, to tell it what variable, and remember x is our number of copies, and so if I press enter it will tell me, and so it's 42.56, so rounded that would be 43. So if you wanted to, you could say about 43 copies, and some you may say only 42, because at 43 you'd no longer be able to see it. Whichever way you want to phrase it, but that's what it would be, about 43 copies. And that's how you could solve it using the calculator with the n-solve. Okay, next page. Mary deposited $500 in a bank account that earns 8% per quarter. So 8% is what's hard to see there, and this is 500. It says write the equation for the amount of money he has at the end of each quarter. Okay, so it would be y equals 500 times 1 plus 0.08 raised to the x power. And the reason it's 0.08, you move this decimal 2 to the left, so that gives you 0.08. Remember, this is growth because he's deposited and he earns this amount, and so it's growth. So you could put it like that, or you could simplify and write it as y equals 500 1 plus 0.08 raised to the x power. Now the next part says, how much money will Mary have after 5 years? And there are 4 quarters in a year. And so we would go y equals 500, and I'm going to use 1.08. And since there are 4 quarters in a year, we'd go 5 times 4, which is 20. Now this is alright, so this is going to be, and there's actually, if I'm thinking right, there's actually a more complicated formula for this, but what we have here, this is the way it would work. So I would go 500 parentheses 1.08 raised to the 20th power, and we get $2,330.48. Okay, the next part is asking if it is growth or decay, and this one here is growth, and the reason for that, we know that, is because b, which is this amount right here, is greater than 1. This one says 0.22, so this is decay, because b is greater than 0 but less than 1. And this one here is 0.89, which, remember, that's your startup, but your b is right here, and so that would still be growth, and that's because b is greater than 1. Okay, the next part here. Given the following data, identify the situation as direct or inverse. Find k and write the equation of the variation function. Then fill in the missing values in the table. So the first part here, it says we're going to take y times x, so 5 times 2, which is 10, 4 times 10, which is 40, 8 times 20, which is 80, and then if I take y and divide it by x, I get 5 divided by 2, which is 2.5. I would do 10 divided by 4, which is also 5.2 or 2.5. 20 divided by 8, which is also 2.5. So that means that this needs to be 2.5. And because of that, that's my k. And since k was y divided by x, that makes it a direct variation, and it's 2.5x. So now to find 22, I would take 2.5 times 22, which would give me 55. And you could fill in the empty spot if you want to, which would be 55 times 22, which is 1210, but obviously y times x is not the same. The next one here, 2 times 5 is 10, 4 times 2.5 is also 10, 8 times 1.25 is 10, so that means this needs to be 10, because that would be 10. And so we can see it's going to be y times x. Now you can double check your y divided by x. This would be 5 over 2, which is 2.5. This would be 10 over 1, which is 10. And this would be 2.5 over 4. And then this would be 1.25 over 8, which you can see none of those are the same. So that makes this indirect. and your k would be 10, so your equation would y equals 10 divided by x. Okay, the next part here. Given x and y, given a xy pair and information about the relation, write the variation equation. So if it's indirect, then our k is x times y, or y times x. So 2 times 6 is 12, so k equals 12, so therefore y equals 12 divided by x. This says it's a direct variation, so that means I'm going to take, to get my k, it's going to be y, or actually I'll write it with variables first. K is y divided by x, and so I would take 1.5 and divide it by 6, which gives me 0.25, and so my equation is y equals 0.25x. Okay, going on to the next page, number 10. When you swim underwater, the pressure in your ears varies directly with the depth at which you swim. At 10 feet below the surface, the pressure is about 4.3 pounds per square inch, or psi. Write an equation that relates your ear pressure y to your swimming depth x. Okay, so they gave us a coordinate of 4.3 pounds per square inch, and then t, 10 feet below water. It tells us that the pressure varies directly with the depth. So this is my pressure, 4.3, and it varies directly with my feet, or the depth, and that's what my k is. So if I divide that out, my k would be 0.43. Okay? Since it says varies directly, that's how I knew it was y over x. Okay? With this being my ordered pair, y over x. So my equation then would be y equals 0.43x. So knowing that, I know my independent variable is going to be my swimming swimming depth is what it says. So, yeah, that's y divided by x. Okay, I was thinking backwards. Sorry. And this is pressure, or psi. And then I would label this, and I would just count by ones here. And we know it's going to go through the origin because it's a direct variation. Here I'm going to count by 0.5. Oops, 0.5. This should be 1. 1.5, 2, 2.5, 3, 3.5, 4, and this should be 4.5. I kind of miscounted there. Okay, now you could put this in your calculator, and for this one I'm just going to go Doc B to clear this so I can start from scratch, and go back, and I'm going to put in my equation, which is y equals 0.43x, and press enter, and then I'm going to go Control T, and I can see some of the points there, and that makes it a little bit easier to graph if you have a few points. I like to look to see if there's anything that is close to being a whole number, and I see that 7 is 3.01, so I would put 7 at 3.01, which is almost pretty much on the 3, and that's all I need is 2 points. And you could go down further if you wanted to see if there's any more points, but you only have up through 12 here. But you just need a straight edge and 2 points, and you'll be close enough. And so this is my graph. Okay, that was B. Sketch a graph of the function. Remember to label the axes and choose an appropriate scale. Okay, the next one, predict the pressure in your ears if you swim at 50 feet. You could just put it in the equation, y equals 0.43 times 50, or you could scroll all the way down on your table, but I think it's easier just to plug it in and go 0.43 times 50, and you get 21.5 psi. Okay. Letter D, it is unsafe for amateur divers to swim where the pressure is more than 65 psi. How deep can an amateur diver safely swim? Okay, so I would put it in my equation, 65 equals 0.43x, and you can solve that by hand, or you could use NSolve. It really doesn't matter, but I think it's less keystrokes to just take 65 and divide it by 0.43, and you get 151, and if we round it to the nearest tenth, that would be 0.2. So 151.2 feet. Okay, the next one, Boyle's law states that for a constant temperature, the pressure P of a gas varies inversely with its volume in a lab experiment. A pressure of 46 pounds per square inch, psi, compresses the gas sample to a volume of 360 cubic feet. So write an equation that relates the pressure P and the volume V. Okay, so basically I have an ordered pair where I have the volume, which is going to be my X, so that's 360, and my Y is going to be 46, and my K is just multiplying them together, so 360 times 46, which gives me 16,560. And so write an equation that relates pressure P and volume V. So again, it was P varies inversely with the volume, so P equals my K, which is 16,560, over V, which is my volume. What pressure would be necessary to compress the gas to a volume of 276 cubic feet? So I would take 16,560 cubic feet, telling me it's talking about volume, but it did tell me it was volume, so that's 276. So I would take 16,560 and I would divide it by 276, and I get 60. So the answer would be 60 psi. Okay. Going on to the next page. Okay, this one's a review of stuff we did a long time ago, but it still relates to exponents, so we threw it in here again, plus some of you needed the extra practice on it. So give the prime factorization of each expression. So this first one is 23. Well, the only factors of 23 are 1 and 23, so that is prime. To prime factorize 24, it would be 2 times 12, with 2 being prime. Then we'd go 2 times 6, with 2 being prime. And then 2 times 3, with both 2 and 3 being prime. So I have 2, and since there are 3 of them, it would be 2 to the third power times 3, and that would be the prime factorization. This one here would be 5 times 5, and then I have 2 x's, so it would just be 5 squared x squared, and that's what the prime factorization would be. Okay, this one here, we would do 140, and you can start with you know, the doing a prime number first, or you can choose any numbers. It really doesn't matter. I probably would have done 14 times 10 because I know that 14 times 10 is 140, and it doesn't take much mental capacity to figure that out. Then 2 times 7 is 14, 2 times 5 is 10. All of these are prime, so I end up with 2 2's, so 2 squared times 5, we usually write them from least to greatest, and then times 7, and then we just put down the exponents, or the variables, x to the third power, y, z squared. So in prime factorization, you just write down the variables. Okay, find the greatest common factor of these. Now, to find the greatest common factor of the numbers, you could use your calculator for that. And to do that, you would be on your scratch pad, and you go menu and number, and it is called the greatest common divisor, and you put in the number 15, comma 6, and press enter, and it tells you that it's 3. And so I know that it's going to be a 3 that I can take out of each of these, and 3 goes into 15 5 times, 3 goes into 6 2 times, and then I'm going to look and I'm going to see at the variables, and I see they both have x's, and the smallest exponent that they share is x to the third power, and then this leaves an x there. Then I look at the y's, and I see the smallest that they share is y squared, and so that leaves a y over here. This does not have a z over here, and this one does, so we can't pull it out, but it would stay over there. So my GCF is what's on the left here, which is 3x to the third power y squared. And then going to the next one, again, you could use your calculator, and you don't have to go up and get it again, because you could just arrow up and capture it, and then just change the 16, and then this would be 64, and press enter, and you get 16. So their GCF for the number is 16. Then look at your variables. They both share a's. The smallest exponent would be 2, so that means that there is no a's left here, but there are 6 left here, and 16 goes into 64 4 times, so there would be a full 4 there. Here there would just be a 1, so I'm just going to leave it blank right now. They both share at least one b, so we're going to pull out a b because that's the smallest exponent there, and that leaves me with 4 b's here. And so my GCF is 16a squared b. Okay, the next part here is to factor the following. So right here I have 9x squared minus 4y squared, and that right there I can see that I have 2 perfect squares. So this is a perfect square, 3 times 3, and x times x. This is a perfect square, 2 times 2, and y times y. So basically you just take the square root of those. So we get 3x minus 2y as one of our binomials, and then the other is 3x plus 2y. And you could check that on your calculator too. And this, just a reminder, I'm not going to do this every time, but I'm going to go doc B. And then I go back to the graph here, and I'm going to put 9x squared minus, actually, because I can't do the y, so I'm going to put 4 and just ignore the y right now. And I'll press enter. And then I'm going to go tab to put the second equation, which is parentheses 3x minus 2 end parentheses, and then parentheses 3x plus 2, and then press enter, and you're going to see it's the same exact line on the graph. Okay, this next one here, I would pull out the GCS because I can see they're both divisible by 4. So if I pull out the 4, 4 goes into 16 4 times, so that would be 4x squared. 4 goes into 16, again, 4 times, so that's 4x, and 4 goes into x 1 time. So right there I have that. Now if I want to, I need to check to see if I can factor that more. So I have the two different methods. I have the tic-tac-toe, which means I put the first term here, the last term here, oh, I forgot my plus sign there, and the middle term here. And then 4x squared times 4 is 4x, or 4x squared times 1 is 4x squared, and then I would write the factors. So 1 and 4, and 2 and 2, and 2x plus 2x would give me 4x. This would be 1 and this would be 1, because 1 times 1 is 1. So this has to be 2x, and this has to be 2x, because 2x times 1 is 2x, 2x times 1 is 2x. So it does factor, it would be 2x plus 1. Again, you could check that on your calculator as well. You could put this in, and then you could put in your final right here, which would be 4 times the quantity 2x plus 1 times 2x plus 1. Or you could put 4 times 2x plus 1 and then square it because there are 2 of them. Okay, this next one here, I would pull out the GCF. They're both divisible by 4. So 4 goes into 4x squared, x squared times. And 4 goes into 64 16 times. Again, this is the difference of 2 squares. So if it's a difference of 2 squares, we take the square root of the first one and the square root of the last one, and 1 is minus and 1 is plus. Square root of 16 is 4. Okay, the next one here, I would look to see if I have a greatest common factor. And I see that 3 goes in each of the coefficients, and they all share at least one variable a. So I'm going to pull that out, so I know it's going to be 3a times. And so 9 divided by 3 is 3. If I take 1a away, that leaves me with 3, and I still have 7 b's. Minus negative 6 divided by 3 would be a negative 2. I took 1a away, so that leaves me with 2 left, and I still have a b, and 9a divided by 3a would be a positive 3. And I can't factor that anymore because this is not to the second degree, and so I'm done. The next one here, again, I'm going to look for a common factor. And so I have 4 goes into 12, and 4 and 16, so I know I'm going to pull out a 4. They all share at least one x. They don't share any y, so my GCF is 4x. 12 divided by 4 is 3. If I take that x away, I don't have any, but I do have y squared. 4 divided by 4 is 1. I don't need to put the 1 down. You can if you want to, but you don't need to. I took 1x away, so that leaves 1 left, and it still leaves the y. And then I have 16 divided by 4, which is 4, and I took the x away, so I no longer have that. So now I would look to see if I could factor this, And the only way I could factor this, since this middle term is xy, is if this had a y squared with it, an x squared, because we already have the y squared. So it doesn't, so I am done. That's as far as I can go. Number 15. Simplify the following expressions. Remember to not reduce fractions, we simplify fractions, and do not use negative exponents. Okay, so what I have here is I'm multiplying these, so I'm going to first deal with the coefficients, and I just have a -2. Then I have my x's, and since I'm multiplying, it's just adding the exponents, so 3 plus 5 is 8, so that would be x to the 8th power. Then I have y, and I have a -2, and this one has 1, so -2 plus 1 is a -1, which means that I would have y to the -1, which means my y goes on the bottom, because remember, I'm not having negative exponents. If I had negative exponents, it would be y to the -1st power. And then this is z to the 1st power, and z to the 9th power, and 9 plus 1 is 10. Okay, and the next one here is raising it to the 3rd power, so it's a power of a power. So I'm first going to deal with the coefficients, so it's a -3 times the -3 times the -3, which is a -27, and then multiply the exponents. 4 times 3 is 12, 2 times 3 is 6. The next one here, I have x plus y and x plus y, and we're multiplying. So my base is x plus y, and we add the exponents. So it's to the 8th power. Okay, d, we're multiplying, so we add the exponents. 11 plus 3 is 14. Next one here, we're raising it to a power, so we multiply the exponents. So 11 times 3 is 33. This one's we're dividing, so I would simplify the fraction, and so 13 goes into 26, so it would leave me with a -1 on top and a 2 on the bottom. And then I would just look at this and I would say, do I have more x's on the top or on the bottom? And I have one more on the top. Then I'd look at my 11s, or my y's, and I see I have 11 here minus 3, so that's really 11 minus a -3. So that would be double negatives make a positive. So that would be y to the 14th, or you could say since it's negative, it really flips. It's the reciprocal, it goes up. It's the inverse, if you want to say. Then the bottom here, or the z's, you'd say, do you have more on the bottom or on the top? And you have more on the bottom, so one more on the bottom, so it would be z. And so that would be the answer. Okay, this next one, again, I would simplify this, and both of those are divisible by 8. 8 goes into 24 3 times, 8 goes into 16 2 times, so that means I have 3 on the top. And then I have the same number x's I have on the bottom, so that means that those are canceling out, so it would give me 1. So I don't put any x's down. Then I have a -5 minus 5, because when you're dividing you subtract the exponent. So that gives me a -10, so that tells me that that's going to be on the bottom, and it would be y to the 10th power. And then we have 1 here and 3, so I have more on the bottom than the top, so that means that I would have a to the 2nd power here, because I have 2 more on the bottom. And I've almost forgot my 2 there. So if you want to write that a little bit nicer, that would be 3 over 2 y to the 10th a squared. Now just a reminder, if it did have negative exponents, then we would write it as 3/2, and then it would be y to the -10, a to the -2. Okay, and that is the review. You can study your notes and practice with all of that, but if you know how to do that review, you should be fine on the test.